Hello, this is CIT 371, Linux System Administration, and today we're going to talk about services and process management. So, as the title of the lecture implies, I'm going to spend some time discussing some background information on Linux services and processes. I'm going to talk about managing these two as well as manually creating services. Then I'm going to provide a brief overview of the lab for this module. So a service refers to a process or application running in the Linux system's background. So when you start an app or an application just runs automatically, there's a service behind it um, that is used to support its functionality. That's also the case with a lot of services that support the functionality of Linux in general, where they support it and applications with specific features and functions. For example, for your VM or your Linux VMs, to have network connectivity, there has to be a network service running in the background for you to be for that to work. There's also services for logging, and scheduling, and power management, and a whole sorts of other Linux tasks and features. So what's interesting about services, they actually are child processes of the init program. So this program is very special because it's the very first one to start running when your Linux machine boots. Now there's also specific Linux services that are called daemons. These run in the background without user interaction. So basically, they're ones you don't have to start or interact with for it to work. So that's what a daemon is. So there are multiple commands you can use to manage Linux services, and some programs actually have their own. Like Apache has Apache CTL. It's actually a script, but a specific command that we use in this course for managing services in Linux is the systemctl command. So it has a lot of different features, including checking the status of a service. I would say it's probably going to be the most common one you're going to use in this class. There's also stopping, starting, restarting a service. You can display its properties with the command. You can also configure it to start automatically or not start automatically when a system boots. So if you install software and it needs to start every time your Linux machine starts, then you need to use systemctl to make sure it does this. Finally, you can disable service from being started at all with systemctl. Think about this command. I've given you the general command, but you're going to have to look at the options on how to perform these tasks in the lab. So that's going to be your independent research for the first part of the lab in this module. So to create Linux services, you can use the systemd service manager. So that's services are actually initialized by this service manager. The way this works is that there are configuration files called .service, and they contain rules governing how a system is initialized, stopped, and managed. These files are usually located in this listed directory here as etc systemd system. They allow you to use the systemctl command to manage the services you create with them. So I'm citing a Medium or article from Medium here, which says that not only so it not only contains the information that I just mentioned, but it also provides an overview of how to create a service for programs that do not have a systemd service. This is actually something you're going to be doing in the lab, but if you want some more information, I highly recommend this article from Medium here. So we talked about services. We're going to move on to processes now. People can get these mixed up. It's important to important to understand they mean different things here. A process is a running instance of a program or command. So basically, when you run a command like a ping command, and you have it be going continually, it's a process in the background for that. If you have Apache running, there is a process in the background. Basically, it's a running instance of something. A service actually supports the functionality of a program, but a process is a running instance of that program. Basically, it's an instance from your user running in the background. Now, what's interesting about processes is that they're assigned unique IDs called PIDs, process IDs. To run a command's or program's process in the background, you can use the ampersand symbol in front of it. So, for example, you can have or you can use the ampersand symbol. So, for example, if you want to run the app command to install something you don't want to see, just put the ampersand here. So, there's an article from Geeks for Geeks I want to cite here that talk about multiple types of processes. There are parent and child processes. Basically, the parent processes are create child processes. They're basically sub processes. Um, orphans are child processes that become separated from their parents due to the latter being terminated or killed before the former. Zombie process is a dead process that still appears in the process status lists. And then finally there's daemons. They are background system related processes, often running with root permissions. These processes service requests from other processes. So there are a lot of different commands for managing Linux processes, similar to how there's many commands for running or managing Linux services. Now, I'm going to talk about multiple process management ones because they all do something a little different. So the ps command lists all the running processes, including now when you run this command, you get information like the PID or the user ID, or in other words, the user that's running the process, the terminal type it's running in, its CPU time, and other information. Top command lists all running processes. What's interesting about top is that it actually updates continually. It basically is constantly running as you look at it. PS is just a static list, but top is a live list. Provides live updates as you run it. So the BG program runs processes in the background, while the FG command you can run processes in the foreground. So you can control how processes work with each two commands. Here's the nice command now. So if you want to add priority to a certain process over other processes, so for example, if you have a process that you want to allocate more resources to, you provide what's called a nice value. So basically it's a priority value. So it ranges from -20 to 19. Now, -20 is the highest priority you can give to a process. So if you really wanted to have priority over a system's resources, you give it the nice value of -20. Renice is a command that lets you edit the priority value of a process that is currently running. So you can run a process with the nice command, but you have to renice it to fix that value that you've assigned. And finally, there's the kill command. Now, it has multiple numeric options depending on how you want to interact with the process, but typically it's used to interrupt at the very least or flat out kill or terminate a process. It should be noted that the shutdown and reboot commands technically are process management or Linux process commands. The reason being they shut down everything. They shut down every process on your system. Okay, the lab overview. I've divided this lab into 3 parts. It's quite a bit longer than the software installation lab. It's your first full lab. There's going to be technically 4 parts to it. The first part in every lab always is making sure you got your internet running and stuff, but part 2 is going to have you research how to use the systemctl command. You're going to have to do some independent research on that. If you use the specific wording I used in my prompts for you to use the systemctl command a certain way, you should be able to look up similar or exactly how I wrote it, and you should be able to find what you're looking for. Part 3 is going to provide you an article. So you're actually going to create a daemon or service for the Git program that you installed during the software installation lab. Now finally, you're going to work with the test SSH connection to experiment working with processes. So what I recommend for this lab, when you're not given an article, find your own how-to articles with specific search queries to help you learn how to use the commands given in the lab. So here's an example of what I was talking about earlier. If you look up how to start the cup service with systemctl, you should have a better time in this lab finding the answers that you're looking for. But anyway, that will do it for this lecture. Thank you very much for listening. If you have any questions, please feel free to reach out, and thank you very much for your time, and have a wonderful day.